All right, so hi everyone. I'm making this video because we have a small issue. The website that I have been using for a few years to help us solve these Simplex problems suddenly doesn't work anymore. So I needed to come up with a new one, and I found a new website that does work. So I'm not going to remake all the videos for chapter 4, but anytime I reference using the Simplex website to get the solutions, or anytime in the video it kicks over to that website, we'll just be using this new one. I put the link in the announcements. It's also in the modules page, but the link will take you to this website right here. And so unfortunately, one of the things I don't like about it is there are a lot of ads on this site, but just have to work around it because it is what makes things easier. And so when you come to the page, you'll have to scroll down to here. And at this point right here is where we're going to have to tell it what's going on. So I'm going to click back over. We're going to solve this problem, which I've got set up here. You'll see that we have 3 variables, and we also have 2 constraints. Now I know that technically, while these are also constraints, we don't have to list them as constraints. The system will set that up for you. And we also have our objective function down here, right? So we'll go over to the website, and the first thing I'm going to do is I'm going to tell it the number of variables. We have 3 variables in this system, and we have 2 constraints that are not non-negative conditions, so 2 constraints. Then I'll click Generate Model, and it's going to bring me to here. Now, drop-down menu here, I can either do a maximization or a minimization problem. This is a maximize. Our objective function had x sub 1 being coefficient of 8, and then 12, and then 22. Our first constraint, which was from the iron in this problem, was coefficient of 17, coefficient of 27, coefficient of 34, and less than or equal to, and we had 91,800 units of steel. Our second constraint was the aluminum constraint. The coefficients were 12, 21, 15, and had to be less than or equal to, and we had 42,000. Was it 42,000? Yeah, 42,000 units of aluminum. And so I've got my objective function. It's a maximization problem. The coefficients are there. I have my first constraint here, my second constraint here, and I'm going to click Solve. It's going to do its thing for a little bit, and then it brings us to here. Now, it gives us a little bit more information than we need, but it does talk about creating a slack variable for S1, go away add, a slack variable for S2, and so it's showing up here as those slack variables. It will show you different steps in the iteration, but here is what's important. And it's showing us our optimal solution. It gives us a value for Z of 59,400. It tells us that x sub 1 needs to be 0, x sub 2 needs to be 0, x sub 3 needs to be 27,000, and it gives us the value for the slack variables. Right? There's a lot of other things that it gives you. This members only content down here. I'm not even sure what that is, but I'm not too worried about it. This is what we need. So I'm going to grab that information, copy it over to my web page or my note page, and then we'll take a look at what it means. So back over to here. Okay. The optimal solution that it found for us is it said that x sub 1 should be 0, x sub 2 should be 0, x sub 3 should be 27,000? No, 2,700, sorry. S sub 1 is 0, and S sub 2 is 1,500, and our Z is 59400. Okay. All right, so now I have to interpret what that means. So the x sub 1 being 0 means that we are going to produce, no racing bikes. The x sub 2 being 0 means we're going to produce no touring bikes. The x sub 3 being 2,700 means we're going to produce 2,700 mountain bikes. The z being 59,400 means that we will make $59,400 in profit. And then the last thing we have to do is interpret, what do these mean? Well, slack 1 would be any slack in the iron constraint. So slack 1 being 0 means that there was no unused iron in this problem. If you were to take this optimal solution here, put this into that first constraint, the left-hand side would work out to be 91,800. The right-hand side is 91,800. So there's no slack or no leftover iron. Slack 2 being 1,500 tells me that if you were to take that solution and put it into the aluminum constraint, because that was the second one I typed in, there would be, the left-hand side would work out to be 1,500 less than the right-hand side, or there are 1,500 units of aluminum left over in the end. Right? So the problems are going to set up the same as the videos. The only significant difference is it's a different website. In some ways, you might argue this one's actually better than the one we were using, because PHP Simplex in the videos, if you look at it, that website never gave us those slack values there. We had to calculate it for ourselves, but now it calculates it for us. All right, I hope this helps. If you have any questions about this, or if it's confusing in any way, shape, or form, please reach out. Please send me a message, email, text, something, and we can always meet either virtually or in person and cover any questions you have about how to use the website or how it's going to work. I will go in and change the requirements so that that website will be allowed in the midterm exam as well. Hopefully you've had a chance to schedule yours. All right, have a great day.